real quick video about vector subtraction. This is actually done in your book on page 772 at the top on figure 8 if you're using Stewart's book. But it's people tend to glaze over it, or they just don't tend to notice it. So it's how do you subtract two vectors? Well, here's two vectors, and just by the definition of subtraction, what you could do is you could just negate u. Okay, so we're just going to flip u by a minus sign, and then just add them together. So what I did is I slid v into position so that the tail of v is at the tip of u. So there's v plus minus u. Okay, so that works. All right, and it happens to put it at the tail. The location you end up having it in is at the tail of u, and sometimes that's fine. That's appropriate. But there's a better way to do it in a lot of cases that has a bit of significance, and we're going to definitely use it in a later video. And that is, I claim that if you put the vectors tail to tail, so I'm going to take, here's u, the original u and v, remember they were just like this, I'm just going to slide them so v is actually tail of v is at the tail of u, and I claim this vector here going from the tip of u to the tip of v is v minus u. Now that should be plausible because notice it does look like, well actually it isn't looking exactly like the same vector, so something's weird, but trust me, it's the same vector. Oh, because the scale got changed, I think, somehow. Okay. But there's an easy way to figure that out. It's v minus u if, when added to u, you should get v. Okay, let's see. U plus v minus u. Yeah, these guys are tip to tail. U plus v minus u indeed gives you v. Okay. So that's an easier way often to do it. If you put the two vectors tail to tail, then connecting the tips gives you the difference. The only tricky thing is where is the arrow. It goes from the vector that's subtracted to the vector that's not subtracted. So from the one with the minus sign to the vector with the plus sign. So the disadvantage maybe is that it ends up based at the tip of u. It might not be the ideal place for it. Well, in a lot of cases that's exactly where you want it. Because, for example, suppose that a and b are points. And a lot of the time we take points and we promote them to be vectors by taking the origin. Let's say u and v are both based at the origin, which is pretty common, if they are the vector versions of 2 points in the plane or in three-dimensional space, or in n-dimensional space, really. So we have these 2 points, and we want to create a vector that's the journey from A to B, like between 2 cities, for example. Then one very good way to do that is you make vectors out of A and B. So the components of u and v are just the coordinates of the components of u and v are the coordinates of A and B. And then you just subtract those vectors. Well, that's exactly what people tell us to do to create the separation vector between 2 points. To take the vector between point A and point B, you just take the coordinates of A and the coordinate of B, and you subtract the coordinates of A from the coordinates of B. Okay. Well, this is another way to say that. It's really saying there's a two-step process you can think of being done there. You've promoted A and B to be vectors on their own, the vectors u and v, and then you just do good old-fashioned vector subtraction. So it really is kind of nice how it fits in.